Hey everyone, I told you that today we would go over our review packets to make sure that you guys know what you're talking about. Your test literally looks exactly like this paper. So if there's something that you don't understand on this paper, by tomorrow you need to make sure you understand that. So if any of you are interested in doing like practice problems, in a Zoom on tomorrow, maybe before you open your test. We could maybe do that. Just let me know. Send me an email if that's something that you'd want to do. And if enough people are like into it and want to do that, maybe we can do that. And whatever's going to help you guys. Okay. So let's see here. The first one here. On this first page, it's really important to realize that you need to make sure you say if it's radical or if it's rational or not, and then be able to explain why. So number one is rational, negative 27. I could write it as a fraction, right? Negative 27 over 1, that's the best way to prove that. So if you can write it as a fraction, then that is an excellent way to prove that it's rational. Because we know rational numbers are any number you can write as a fraction. So since I wrote it as a fraction, that's proof that it's rational. Same thing with number 2, 0.2287. It's rational because it's a terminating decimal. How do I prove that? I write it as a fraction. This goes tenths, hundredths, thousandths, 10 thousandths. That goes 2287 over 10,000. There's that number as a fraction. It must be rational. Number 3 is irrational. It does not have a pattern. It goes on forever. That's irrational. Number 4, 0 is rational, right? How do I write 0 as a fraction? Well, I can just write 0 over 1. That proves that it's a fraction, and it must be a rational number then. Number 5 is irrational. Square root of 39, because it's not a perfect square. Remember, if it's a square root or a cube root, the only way for it to be rational is if it's a perfect square or perfect cube. If it's not, then that means that it's irrational. So the square root of 39, if you put that in your calculators, is going to give you a decimal that goes on forever with no pattern. That's going to be an irrational number. However, square root of 25 is a perfect square, right? We know that square root of 25 is 5 and negative 5. That means I could say this one's rational because it's a perfect square. That's the other way that we could do this. You could have said it equals plus or minus 5, and then you could put that over 1. That's okay. But you could also just say it's rational because it's a perfect square. That only works with perfect squares, perfect cubes. Number 7 is the long one, right? It's a repeating decimal, so I know it's rational. If you want to prove y, set it equal to x. 3 digits repeat, so we multiply by 1,000 on both sides. That gives me 1,000x equals 348.348348. Rewrite this part as 348 plus x. Subtract 1x from both sides. That gives you 999x equals 348. And then divide by 999. There's your fraction. I proved that it was rational. I can write it as a fraction. Yeah, that's good. You don't even have to simplify it here. As long as you're proving that it's a fraction, you're good. Number 8, 900 is rational because you can just do 900 over 1. That's just a natural number. Number 9, the cube root of 511 is irrational because it's not a perfect cube. Number 10, square root of 81 is rational because it's a perfect square, just like we said before. Number 11 is one just like number 7. It's a repeating decimal. Sorry. So you can set it equal to x. 2 digits repeat, so this time we multiply by 100. That's going to give you 100x equals 32.3232. 100x equals 32 plus x. Rewrite that part as plus x. Subtract that 1x from both sides. That gives you 99x equals 32. And then divide by 99. And there is your fraction. So definitely rational. Here's why. Because it's 32 over 99. Number 12 is irrational. Remember, this is the one I gave as an example of when they try to trick you. It's not a repeating pattern because they keep adding a 2 in there. So since it goes 2, 5, 2, 2, 5, 2, 2, 2, 5. It goes on forever, but it's not the same digits over and over and over because they're adding a 2 each time. Irrational. Always irrational. Number 13, 62 pi. If it says pi, it's irrational automatically. No matter what we do to pi, if we add, subtract, multiply, or divide, it's always going to be irrational. So if we do 62 times pi, irrational. 14 is a fraction. That hopefully is the easiest one on here. If it can be written as a fraction, it's rational. It's already a fraction, it's definitely rational. And then the last one on the front, 15, the cube root of 216, is a perfect cube, therefore it's rational. Okay, this front side on your test tomorrow, you're going to pick 10 of these to do. You don't have to do all of them. You're going to pick 10. And the 10 that you feel most confident about. If you can write it as a fraction, it's rational. Prove to me, show me the fraction. Okay? All right. Second page. Volume of a cube is 343 meters cubed. What's the side length of each side? If you hear cube, we should think cube root. Right? If it's volume, we're doing the cube root. So I'm going to do the cube root of 343. That's all you need to show. Oh, make sure on your test that you turn into me, you show your work. If you don't show your steps, that's what I grade for your test. So if you don't show those steps, you're going to miss a lot of points, okay? So I would need to see that you knew it was the cube root of 343, and then just write equals 7 meters. That's all I need for that one. Make sure you show the cube root. Number 17, the area of a square picture, if you hear square, you should be thinking square root. Is 256 inches squared. How long is each side? So this time we're going to square root 256. We only need the positive answer because we're talking about the length of a square. So the answer is 16 inches. Again, make sure you show this part. Okay? You can be taking notes right now and use that notebook on your test. So all of these problems, all of these questions that you might have that I'm answering, write them down so you have them to use for tomorrow. All right, 18 through 23 were like the homework from 2 days ago, where you had to solve the root. So the first one, we got square root of x equals 17. If I want to get rid of a square root, I need an exponent. If it's a square root, I need an exponent of 2. So I'm going to use an exponent of 2 on both sides. Those cancel out. We're left with x equals 17 times 17 is 289. That is number 18. Again, if you don't show me that you squared both sides, I'm taking points off. All right? I'm not messing around with this. I'm just trying to prepare you for what it's going to be like. So you can't say, well, I didn't know you were going to take. You definitely know. Because I'm telling you right now, show those steps on your paper, however you want to write that. The second, number 19, we have x to the third power equals 64. So if I want to get rid of an exponent, I need a root. It's a 3 exponent, so we need a cubed root. Cube root, both sides. this cube root and this 3, they're going to cancel out.